tried it. We've tried VR headsets on the plane just to see if they work, and you get looks from everyone, and it gets quite awkward. So I think that's the main problem at the moment.
Okay, thank you all for coming to our presentation, and here's our team. We're doing this research with Professor Seth Steiner at Georgia Tech. So basically, what is our research? Take a look at this picture. These are the famous models in the market about AR hardware displays that displays the image in front of your eyes. And take a look at the highlighted areas. Those areas is slightly more opaque than the surrounding areas. And those are the place for optical combiners. So optical combiners are the optical elements in hardware displays that reflects the image from the real display into your image so you can see the augmented content. Well, this actually isn't an issue. This is from user's perspective. You can easily see that optical combiners can occlude the user's vision when the displays are turned off, which is primarily the use case for a lot of AR applications. So our study focused on to find the optimal position for these optical combiners such that the users are comfortable even if the displays are still turned off. To get a better sense for our study, please wear the glasses just distributed to you by our colleague Parth and Professor Seth Steiner throughout this presentation, and we will do a slide vote at the end of the presentation. So our first experiment focused on determining the position, area, and shape of these optical combiners. The way we do this is to construct 7 different pair of models mimicking the optical design in the real market. And as you can see, we collected feedback from 30 participants for verbal feedback and quantitative preference ranks, and we get this chart. From this chart, we can easily see that the models 7 and 6 are the most preferred models. Comparing these two models, the participants left feedback saying that they cannot feel as much visual occlusion in model 7, just as if they cannot feel much visual occlusion as they feel in the using the nose in their normal vision. So as a result, we decided to choose the 7th model as our prototype to move forward with the experiment. We realized that the edge between the semi-transparent film or the occluded area and the normal glasses actually plays a very important role in determining the participants' comfort. So we naturally want to figure out what is the best angle towards the nose in this case for the participant, for us to place the optical combiner. Here's our second experiment. So we constructed 7 different pair of glasses with the angle of between the optical combiner and the normal glasses ranged from 0 degree, which is right in front of our view, to 30 degrees towards the nose. And after the calibration of the angles using participants' interpupillary distances, we asked participants to view the art gallery exhibition on a big screen, just like similar to what you are doing right now. And every 2.5 minutes, they are going to use a different pair of glasses with a control pair of glasses and leave their quantitative feedback using Likert scale for comfort. And as a result, we get 2 different graphs using perceived angles and calculated angles. The calculated angles are based on their interpupillary distances, and by close examination of this graph, we can see that minus 15 degree, which is 15 degrees towards the nose, seems to be the relatively comfort position for us to put the edge between the optical combiner and the real glasses. So this can be a suggestion taken by hardware display manufacturers into future manufacturing of hardware displays. As we are reaching to the end of our presentation, we want to do a quick vote about your experience wearing the glasses. So for people who get the glasses with a red marker, please raise your hand if you feel it is comfortable. Okay, So for people who are wearing a glass with a blue marker, please raise your hand if you are comfortable. For people who get a glass with yellow marker, please raise your hand if you are comfortable. Okay, you can see that the participants who raise their hands are actually increasing. So this collides with our experiment result because the red marker stands for the 0 degree, which is right in front of your eyes, and the yellow marker stands for minus 30 degree, which is far to your nose. So this is our result, and feel free to have any questions. Thank you so much for attending our presentation.
Thanks for the nice talk. Any quick questions? Any quick questions from the audience?
I have a short, maybe basic question, but why is the film only on one side of the glass? Is it just for experiments, or it's like that's how it's actually being used?
Yeah, this is called monocular display. The reason why we chose the monocular display is like there's both monocular displays and binocular displays in the market. So if we do a binocular display experiment, the conclusion might not be generated enough or generalizable enough for the entire market to be adopted. And also, monocular display actually takes a great amount of market size in the current AR industry, so that's the reason why we chose this as an experiment.
Okay, that makes a lot of sense. Thank you.
Thank you.
And we will collect the glasses at the end, so you can keep the glasses down and we can collect after that.
Okay, so let's thank the speaker again. So the next two talks will be a pre-recorded video. So let's get the streamline. And so probably these two answers, let's skip the questions and then keep all the questions in the panel session. So the next talk will be Wade Murphy, dynamic